Good morning, class. This is Mr. Eggleston, and this is lecture 7.4, your features of quadratic functions. This is for Algebra 1. The learning targets are 1, to identify a relationship between the vertex and the x-intercepts of a quadratic function using symmetry. Okay. Use graphs, tables, and equations to identify the vertex, intercepts, and other values of a quadratic function. And the last learning target, determine if a parabola opens up, which means it's Elmo, that's up, or down, which is emo, because it's sad and depressed. All right, so let's begin this little fun activity by looking at parabola patterns. We've already seen that quadratic functions follow particular patterns. Today we'll look at some patterns made by their graphs. The graph of a quadratic function y equals f of x is shown. Here it is. Here's the vertex right there. Matter of fact, let's label the vertex. Remember, the vertex is where the graph bends, so it's at -3, -4. It says, identify the axis of symmetry. The axis of symmetry is the vertical line that passes right through the vertex. So that will be x equals -3. And this is the AOS right here. Identify the x-intercepts. Well, that's at that location and this location. So they are at x equals -5 and x equals -1. And then that was pretty easy. Now it says, what is the relationship between the location of the x-intercepts and the axis of symmetry? Well, to answer that, you would realize that, hey, that one x-intercept is 2 units to the left, and the other x-intercept is 2 units to the right. So they are equidistant. That's what equidistant means. It means it's the same distance on either side. Distant from the AOS. Okay. For which x values is f of x equal to 5? Well, here's 5 up here. F of x equal to 5. Well, it's at -6. And x equals 0. What is the relationship between these two values? If you look, they are equidistant on either side of the axis of symmetry. There are 3 units to the right and 3 units to the left. Okay? So they are both 3 units away from the axis of symmetry. Now, with that in mind, if f of 4, so 4 is way over here, I mean, not way over here, but, over here somewhere, is equal to 45, which other x value gives an output of 45? So notice x equals 4. How far away is that from the axis of symmetry? So that distance, d, is going to be basically, the vertex is at -3, so it's 4 minus a -3. It is 7 units to the right. So that means there must be another point 7 units to the left of x equals 4. That would also give you, or 7 units to the left from the axis of symmetry. Okay. That will give you the same output. So if the distance is 7 and our vertex, our axis of symmetry is x equals, what is that, -3, I believe? Yep, up there. So if it's 3 units to the 7 units to the left, we subtract 7 from it. It's going to be at -10. That is, when x equals -10, f of -10 would equal 45 also. All right? Did that make sense? Again, we found the distance, so this would equal 45. What we did was we found the distance that the number 4 is from the axis of symmetry, which is -3, and that's 7 units. Once we figured out that x equals 4 is 7 units to the right of -3, we know there must be another point 7 units to the left of -3, which puts us at x equals -10. So we know f of -10 must be equal to 45. So a parabola has a vertex at 2, 5, and passes through the points 5, -4. Does this parabola open up or down? Well, think about this. Here's 2, 5 right there, and that's the vertex. They tell you that. They say, hey, this is the vertex. And then they give you another point down here. So the only way that the graph can get down to this point is if it opens down, if it does something like this. Okay? So does this parabola open up or down? Down, because the other point is 5, -4, which is below the vertex. Okay? Give one other point that you know for sure, absolutely, is on the graph. All right? Well, think about this. Here's our axis of symmetry. Notice this point right here is 2 units. So you know for a fact that 2 units to the left, it will also be a point. And that puts you at the ordered pair 0, -4. Okay? The parabola has an x-intercept at x equals 4.236. They tell you that. An x-intercept at 4.236. All right, they want you to find the other x-intercept. Well, you notice this x-intercept is going to be, you find the distance between 4.236 and the axis of symmetry of x equals, x equals 2. So the distance between them is going to be 4.236 minus 2, which is 2.236. So that means the x-intercept of 4.236 is 2.236 units to the right of the AOS. That means the other vertex, or the other x-intercept, must be 2.236 units to the left. So if our axis of symmetry is 2, the other point must be 2 minus 2.36, 2 minus 2.236, which is negative 0.236. Sorry, I miswrote that. It's 2 minus 2.236. And so there's the other x-intercept, and you got that from symmetry. by looking at the distance away from the axis of symmetry that the x-intercept is. All right? So here it is. Quick notes. Parabolas are symmetric across the axis of symmetry. That means it's for a given output, it's the same distance away from the axis of symmetry on both sides of the axis of symmetry, to the right and to the left. AOS is halfway between the x-intercepts. You're going to use that to help you figure out where the vertex is sometimes. Okay, halfway between. Points are equidistant from the axis of symmetry, have the same y value. The AOS goes through the vertex, that's important. If parabola opens up, vertex is minimum. I didn't mention that, but yes. You can see it here. There's the vertex. If it opens up, if it's a happy face, that vertex is a minimum. Minimum means it's the smallest the function will have. And if it's a sad graph, if it opens down, the vertex is a max. And that's a maximum right there. So understanding if the vertex is a minimum or a maximum, all you have to know is if the graph opens up, if it's a happy graph, if it's an Elmo graph, it's going to be a minimum because it's a smiley face. Or if it's a sad, depressed emo graph, then the vertex will be a maximum. All right, I hope that helps, and you have a wonderful day.